Hey everyone, so we're looking at another differential calculus optimization problem. As you can see, I have the father of calculus here, Isaac Newton. So we are going to be doing another optimization problem. Let's see how it goes after this. So as you can see, we have a road here. So we have a person traveling, and suddenly they remember that they have not closed the tap at home and they have to turn around quickly. See them go. And they were 20 kilometers away, this person. Then now he wants to go and back and close the tap. So he needs your advice, the mathematician, and says, at how much speed must I drive so that I don't lose money? So there are two problems. There's a rate at which he's using petrol, and there's a rate at which he's using or he's losing water. So we are going to compare these two rates, and we're going to come up with a cost function for the whole situation, and then we're going to try and minimize it. So that is our problem. So they want us to calculate the average speed at which he must travel to keep his cost as low as possible. So this is the combination of the cost of water and the cost of petrol. So this means that if he drives too fast, he'll consume too much petrol and hopefully save a lot of water. But if he drives too slow, he won't consume as much petrol because his consumption depends on the speed. If the speed is higher, the consumption is higher. But if he drives too slow, he will lose a lot of water and it will cost more. So we want to know what the right balance is for those two things. Where is the exact value of x? So what is the value of x that he needs to travel, the exact value of x that he needs to travel, so that both these costs are kept as a minimum? He doesn't drive too fast to use too much petrol, and it doesn't drive too slow to lose all the water that's going to cost him 160 per hour. So to do this, we will say this formula is going to be needed. So we can see that he's 20 kilometers away from his home, and then we know that speed equals distance over time, and then we're not going to need the speed because we already have it, so we need going to make time the subject because that's the one we're going to need. So making time the subject, we get this, and then since the distance is 20 kilometers and this speed is x, which means our time that he'll take from here to home will be 20 divided by x hours. Okay, so now let's continue. Let's see the cost that is going to be in rands. We need to have a formula that is going to be only talking about rands or money that is going to cost him. So we need to have a function talking about money in terms of x. So the cost of petrol, since the rate that we were given is rands per kilometer, So we're going to take that rate and multiply it by the distance. Okay, then the distance will cancel with the per kilometer here, and then we'll be left with rands. So this means that this is going to be a value that is in rands. Okay, so as you can see, we take the cost or the rate of petrol cost and the distance, and then we multiply them, we get 20 multiplied by 1.2 is 24, and this multiplied by this gives us x over 200. Okay, so now we have the cost of petrol in terms of x. Let's see what the cost of water that is being lost is. So that cost of water is going to be our rate per hour multiplied by the time. So the time is in hours, so when you multiply the per hour and the hours will cancel, and then we'll be left with the rand value that is going to cost this person. So let's put those in. So rand value is 160 per hour, and then our time to get home is 20 over x. So this means this is the combination of the cost that is going to be incurring. So we can put this as one equation, and okay, this multiplied by this gives us 32 over x. Then we can put these two together as one equation and say the total cost will be 24 over x over 200 plus x over 200 plus 32 over x is our total cost. So this is me rearranging it so that we can differentiate it. So the x in the denominator, we need it to go up so that we can apply our rules for differentiation. So now this is our cost function. We need to minimize this cost. So we'll say, let's take this and put it up there. So now we will say at the minimum cost, this derivative of this function must be 0. And the derivative is 1 over 200 minus 32 over x to the negative 2. So we've just differentiated this. This was a constant, so it falls away. The derivative of x is 1, so we just have 1 over 200. And here the minus 1 multiplies here, and then we subtract another minus 1, we get minus 2. So now let's put this nicely. We have 32 over x squared, and then we can take 32 over x squared. We see we've substituted our 0 for c prime of x. Then 32 over x squared becomes 1 over 200. Cross multiply, so we're going to have x squared equals to these times this, which is 6400 or 6400. Then square rooting both sides, we get plus or minus the square root of 6400 or 6400. Then this gives us plus or minus 80, and that means he must travel a speed of 80 kilometers per hour. So this is the exact amount of speed that he needs to drive at so that he doesn't lose more money. The cost is going to be lowest as possible. Thank you for watching. Please subscribe and share this video with your friends and leave comments in the next section below.